Hello and welcome to this special edition of Scishow News. Today, NASA announced that there is occasionally flowing liquid water on the surface of Mars. Or at least liquid hydrated perchlorate salts that flow down steep slopes in the warmest Martian months. When they do this, the Martian dust gets darker, a darkness we can see, and that was first spotted in 2011 and named recurring slope lineae, or like lines that appear on slopes roughly at the same place every year. During the winter months, they fade, but then they reappear, stretching down steep slopes of Martian canyons, mountains, and craters. It took some time, a lot of hard work, and some clever tricks to determine for sure that these RSLs, as I'll be calling them, were caused by flowing water, but indeed that is what scientists are publishing today in Nature Geoscience. Of course, like every great answer in the history of science, it brings up a whole new host of questions. Where's the water coming from? Is it being sucked out of the atmosphere by water-loving salts, or is it flowing from super salty subsurface aquifers, as we recently discussed on an episode of Scishow Space? But we do know that central to the existence of these RSLs are perchlorates, corrosive, toxic ionic compounds that are troublingly abundant on Mars. Calcium perchlorate has been found in various places on Mars and is super hygroscopic, meaning that it's able to attract and hold water from its environment. The resulting perchlorate brine, also called a hydrated salt, is so stable that it dramatically lowers water's freezing point and the pressure at which it evaporates, so the brine can exist for fairly long periods of time on the surface of Mars, and likely perpetually beneath the surface. The RSLs were first noticed and written about by Lujendra Ojha in 2011 when he was an undergrad at the University of Arizona. Now a graduate student at the Georgia Institute of Technology, Lujendra has continued working on the project and was a part of the press conference this week. The images in which the RSLs were first identified were taken by the high-rise visual light camera on the Mars Reconnaissance Orbiter, which has now been operating for almost 10 years. This camera has pretty great resolution, able to resolve around 1/4 of a meter per pixel, but figuring out what the streaks are actually made of requires a different instrument, a spectrometer. Basically a camera that takes pictures in way more wavelengths, which gives us a lot more information. Unfortunately, that spectrometer has far lower resolution than the high-rise camera, so scientists had to use some pretty advanced techniques to increase the resolution to get good enough data. But the data are here, and they show that these hydrated salts are deposited inside the RSLs and not outside of them, thus making it clear that these brines are indeed flowing on the surface of Mars. While they are not by any stretch something you might call running water, there's no rivers on Mars, there's definitely mud on Mars. Toxic, corrosive mud. Though to be clear, it might be like 10 millimeters of mud on the surface of dry dirt. We're not sure yet. There's actually a place on Earth that is very much like these super saline streaks on Mars, the McMurdo Dry Valleys of Antarctica, where despite being one of the coldest places on Earth, liquid water persists. Don Juan Pond, the saltiest body of water on planet Earth, has a salt level of around 44%. This keeps the water liquid even at tremendously cold temperatures. Interest in Don Juan Pond and similar Antarctic lakes has skyrocketed since the RSLs were first identified, and I expect that to continue, though the salt in Don Juan Pond are chloride salts, not perchlorate salts. What's the difference? Well, if you've ever ground up some sea salt on your eggs, then you've eaten calcium chloride and, of course, sodium chloride, but calcium perchlorate will kill you in like 8 different ways and also make it really difficult to grow potatoes, just saying. So when we say that the water on Mars is salty and that it's a brine, we don't mean that it's like our ocean. It's salty in that it has a very high concentration of an ionic compound, and that ionic compound is very much not sodium chloride, the stuff that we call salt. Even with the reality that this water is full of a corrosive salt and that it tends to exist at temperatures at which life on Earth can't reproduce, scientists are considering these areas to be places to look if there is life on Mars. However, it might also be a place to avoid. Even before this week's announcement, discussions had begun that these areas should be protected from future missions because of the possibility that Earth bacteria could colonize the area, not only contaminating our samples and making it impossible to determine whether the life was Mars-based or Earth-based, but also potentially destroying whatever ecosystem there may be there in the most epic case of invasive species in human history. Basically, we live in a pretty small solar system, and we won't have a lot of chances to observe completely new biologies and ecologies, and if we have a chance to do that, we really don't want to mess it up. Add to that the fact that these slopes are extremely steep and that we have no idea what the consistency of this Martian mud will be, and it's likely that we won't be directly observing any of these areas for some time. But there's still much that we can learn as we continue to better understand the remarkable hydrology and geology of our red neighbor, and we here at Scishow will continue to keep you informed. If you want to be a part of that by supporting us, you can check out patreon.com/scishow. If you're one of those people who are supporting us, then you're the best. And as always, if you want to keep getting smarter with us, you can go to youtube.com/scishow and subscribe.